Alright, today it is February 14, 2018. That is Valentine's Day. Tell someone you love them. Here we go. So we are going to focus today on learning more things that will help us with problem number 1 and problem number 2. So we want to start learning some vocabulary so we can better understand why we look and act the way we do. And we want to learn some new terms and practice so we better understand how babies are born unique from one another. Let's jump to that. Our last slide we left off on was 6, so we're going to 7. On slide 7 is a chance to practice slide 6, the terms P generation, F1 generation, and F2 generation. Your job is to create a model like you see here, and then label it with, we are model for slide 7, so you want to identify slide 7 in your notebook. You have the P generation, the F1 generation, and then the F2 generation. You need to identify in your family who is the P generation, F1 generation, and F2. Or for fun, you can create your own F2 generation that could be children from you. So you could make up someone you marry and whom you have kids with. And you can make up some kids' names. But if you're using real life, it has to be real grandparents, parents, and you and your brothers and sisters, if you have any. But it's got to be set up in this visual manner with names labeled by those people. Slide 8 is learning about dominant traits. Dominant traits is caused by a gene that is expressed or observable. Each person has 2 versions of a gene, and they might be dominant or not. Anytime a scientist or us students are learning about a gene that's inherited, we have to give it a letter to represent that gene. With dominant genes, we use a capital letter. So anytime you see a capital letter, for example, you can see right here for Einstein, for Curl's tongue, you can see there's 2 capital C's here to represent that it is a dominant trait. It says dominant version of a gene covers up the recessive gene. So if you inherited a dominant version of a gene, it will show up. You'll see it, like whatever you see in the person will show up when, even though they have another version that's recessive, it just doesn't show up. It's covered up by the dominant version. First task here, it says describe which trait is dominant for A, B, and C. So you have example A, example B, and example C. So which trait, and that's what the gene controls for, is dominant. So is Curl's tongue dominant or can't curl tongue? Well, if you look at the letters here, it tells you what's dominant. So you'd write A equals Curl's tongue is dominant. Example B and C, do it on your own. Examine the 2 traits, figure out which one has the capital letters. The one with the capital letters is symbolizing which one is the dominant trait for B and C. Number 2 says if a hybrid, which is you have 2 versions of a trait, which is you have one dominant, one recessive, it says if that were to happen, infer letter symbols for dark hair. So look at dark hair here. Which one of these is showing that a person inherited the dominant and the recessive? Is that big L or big L little l? Well, if they're a hybrid, they have the 2 different versions. So for this answer, for number 2, we would write big L, little l, or capital L, lowercase l, right here in this blank. Number 3, it says apply definition. So think about what the definition up here says. It says, why is a hybrid not a middle appearance? So why does the dark hair person that has a dominant and recessive, why is their hair still dark? Why isn't it somewhere between dark and then the recessive version light? Why isn't it not some way half in between? And to answer that, you have to read this right here. This is why. So as your answer, so when you write your answer to why a hybrid isn't some middle appearance, refer to this last part right here to understand. Slide 9, recessive traits, caused by a gene that may or may not be expressed or observable. So if we say a gene is expressed, that means it shows up in what you can see in the person. And if you can't see a trait with somebody, so if you look at them and you can't see the trait, it means it wasn't expressed. it's represented as a lowercase letter, so a little f in this example, for attached earlobes. And you can see this example right here, it's all F's. So the F letter is used to describe the gene that controls the earlobe trait. It says, a recessive trait can only be observed if an individual's two versions of the gene are both recessive. So the only way a recessive trait will show up is if they have the two versions are recessive. So if you have little f, then you would have attached earlobes. But if you had capital F, little f, like in this example here, you would have the dominant trait. Your recessive trait wouldn't show up. It says attached earlobe is recessive, and that's going to be represented with little f. So it's attached earlobe is a recessive trait, so it's a little f. Number 1, it says identify number of people with attached earlobes. So attached earlobes is like, this is what the trait is, the appearance of it is. So what you have to do is count how many people only inherited little f versions of the gene. So you may notice that we have some people that only inherited the recessive version. So each person, you'll notice, have two f's, but only some people inherited two little f's, or two recessive versions. So this square right here, that's a male, so we draw males as squares in this example. So in the P generation, we have one person that inherited two recessives, so they have attached earlobes. We go to the F1 generation, and we scan it, and this person, this other dude, it's a guy, they inherited two little f's, so that's a second person that inherited the recessive trait of attached earlobes. And we go across to this lady in the F1 generation. This daughter, she also inherited two of the recessive gene. So then we can say that both this person, and this person, 3 so far, have attached earlobes. The last person is in the F2 generation. They have two little f's. Because they inherited two recessive versions of the gene, they also have attached earlobes. They're the only people. So 1, 2, 3, 4. The answer to number 1 is 4. Number 2, it says identify number of people as hybrids. So how many people from P, F1, and F2 have one dominant and one recessive? You count them up. I'll start you on P generation, and then you do F1 and F2 on your own, and then add them up together. So for P generation, we have 1, 2, 3. 3 people in P generation have one dominant, one recessive. We call them hybrids. Now add up how many people in F1 and F2 and add them to the 3 we already counted, and you have the total number of people that have one dominant and one recessive. It says categorize each generation based on number of attached ears. So in the P generation, for example, how many people in the P generation have attached earlobes? So the P generation, we have 1. Only one person in the P generation inherited two recessive versions of the gene. Little f, little f. In the F1 generation, count how many people inherited the little f, and same for F2, and you just put that total there. Alright, slide 10. Alright, the next slide is a word that I'm eager to use. It's called alleles. And alleles are what we call the different versions of a gene. So you have you could say recessive allele, because it's a recessive version of a gene. You could say the recessive allele. If it's a dominant version of a gene, you would call it the dominant allele. But allele represents 2 or more versions of a gene. Examples are, let's say you have a hair type gene. Let's say there's 2 versions of it. The 2 versions you call alleles. You call straight hair allele and curly hair allele. For example, if you're looking at a gene that controls hair type, or how your hair is, whether it's straight or curvy or really curly, that gene is called the hair type gene. And because there's so many different types of hair, we know that there are different versions of the hair type gene. In this example, we have one girl with curly hair, one girl with straight, so we called each one its own allele. We said, oh, here's one version, it would be the straight allele, and one version be the curly allele. Also, you may have noticed I gave a letter symbol to represent the hair type gene. In this example, I just pretended straight hair because it's more common. It's not always the case, but because it's more common, I thought maybe it's dominant, so I gave it a capital S. And I'm thinking fewer people seem to have curly hair, so I called it a lowercase s. But notice the letters are the same. They have to be the same letter. Again, it says the different versions of a gene must have the same letter, one capital and lowercase. Just like in this example, both are S's. For your task, your job is to look at number 1 example here, and then look at number 2 example, and you want to give a name for the gene. So in this example, the eye color is a little different here, so you could say it's an eye color gene, or the eye shape. You see this one's a little more narrow than this eye, so you could say it's the eye shape gene or the eye color gene. And after that, we want to we make it up. We just decide which one do we want to call the dominant allele, which one do we want to call the recessive allele. So just for pretend, we'll pretend that the narrow, we'll say the narrow eye is dominant. So you could say, so you would type right here, the narrow, so we could call this one the narrow and its dominant allele. We'll just pretend. And then we'll give a name for this one. We can say the round recessive allele. Now, it doesn't matter if one's really dominant or not. It's just practicing that we realize that different versions are dominant or recessive, and it's important that we just name them alleles. You would do the same for this one. So do this one on your own, number 2. In your notebook, you would write number 2. You give this trait, or this gene that controls the lips, give it a name. And then go on to just pretend that one is dominant, one's not, and give it a name. Give a name for this lip to this one, and then call them alleles, just like you saw in this example, and just like you see here. Except in my example, I need to make one dominant, which I did with a capital S, and then I identified this one was recessive with the little s. All right, good luck.